Welcome. Reflecting a point through any line. That is a question that I want us to solve. The question is here. What are the coordinates of a point r prime if r prime is a reflection of a point -1, 3 in the line 3y plus 2x is equals to 33? So in this question, you're given a point which is being reflected along this line. The equation that is given, so you're supposed to give the coordinates of the image. So the first thing, which is very important, is to begin by sketching. So I'll sketch, assume that I have, this is the mirror line, and then I will draw another line here that will be connecting the object and the image. So this is the mirror line, and the equation of the mirror line is 3y plus 2x is equals to 33. Then there is a point that you're given. This point is here. The point is -1, 3. That is the point that is being reflected along this line. So you're supposed to give the coordinates of r prime, which is a reflection of this point along this line. So before we continue, there are some basic properties of reflection that you must understand in order to solve this question. There are two important ones. One is the distance between the mirror line, and I can call this point of intersection to be M. So this one, because this one is the object, I can name it as R. Then this is the object, and then the image, let's say the image would be here. The image is r prime. Since we don't know these, we can let it to be xy. This is the image. That is the image. Now the property that you must understand is one, that the distance between the object and the mirror line is the distance should be equivalent to the distance between the mirror line and the image. So in this question, I can just write it like this. This distance, the distance r prime m, should be equivalent to the distance m r. That is a very important property of reflection. Another important property is that the mirror line and this line that is connecting the object and the image should be perpendicular to one another. Knowing that, we can now proceed, and what is going to help us first is to identify the coordinates of this midpoint. So if this distance is equal, this distance r prime m and m r, if the distance is equal, then it means that this point here, the point of intersection of this line, this one should be the midpoint of this line, r prime r. Now we need to get that point m. And how do you get that point m? To get the point m, we need to get the equation of this line, the equation of this line connecting the object, point, and the image. That is the line r prime r. So let us get that, the equation of that line. And what is going to help us? We can get the gradient of this line first. When two lines are perpendicular, remember that property, that if two lines are perpendicular, the product of their gradients should be -1. Now, since we have the equation of this line, we can write that equation in the form y is equals to mx plus c. So 3y, so this is 3y plus 2x is equals to 33. I want to write it in the form y is equals to mx plus c, and this is what I will get. This will be -2 third x plus 11. So the gradient of that line is -2 thirds. So after getting that, the gradient of the other line, that is line r prime r, will be, that is m2. Since the product must be -1, it will be 3/2. Now to get now the equation of that line, get the equation of that line, we have the gradient of that line, and you have a point, one one point r, this is a negative 1, 3. So using that gradient and a point, that is negative 1, 3, and then we can use the other point, the general point that is on that line, that is xy. Pick any general point, xy, and since we know the gradient is 3/2, then if you calculate the gradient using this 2, so change in y will be y subtract 3 over change in x plus 1 is equals to 3/2. Cross multiply these, you get 2 into brackets y subtract 3 is equals to 3. You are cross multiplying x plus 1. So opening the bracket, you get 2y subtract 6 is equals to 3x plus 3. So reorganizing these on, you get 2y minus 3x is equals to 9. So that is the equation of, I can call this line, I can call this line line 2, and the mirror line 1. So now I can take the equation of line 1, which is the mirror line, equation of line 1, which is given as 3y plus 2x, 3y plus 2x is equals to 33, plus 2x is equals to 33, and then line 2, 2y minus 3x is equals to 9. Now, since I want to get the point of intersection, which is M, when you solve these two equations simultaneously and get the values of x and y, that will give you the coordinates of the point of intersection. That is how we're going to do it. So solve these two simultaneously to get a point M. So this one I have to multiply this one. I want to eliminate y, so make y uniform. I will multiply the first one by 2, then the second equation by 3. So these are the equations I will get. 6y after multiplying plus this would be 4x is equals to 66. The second equation multiplied by 3, get 6y minus 9x is equals to 27. So from there I can just subtract. 6y will go. This one will give 4x minus subtract 9 will give 13x is equals to this is 66 subtract 27, this will give 39. So x will be 39 divided by 13, which will be 3. So once you get x as 3, you can now use substitution to get the value of y. So I can use this equation, the second one here, 2y subtract 3x. Here you can see this one. So but x is 3, so this will be 9 is equals to, this one is equals to 9. So this will give 2y is equals to 18. And if this is the case, y will be equal to 9. Now you can see almost there now. I've obtained the x and the y. So the x is here. So the x value is here. Then the y value is there. So the coordinates of point M, therefore, will be given by 3, 9. As simple as that. 3 and 9. So I have this point now, the point here, the point that is here at the center. This is, I can write it, this is 3, 9. 3, 9. Now, having obtained that, it will now be very easy for me to get the coordinates of r, that is r prime. Since I have 3, 9, which is the midpoint of that line, and I have the object. So this is what you're going to do. I think I will extract it here. Let me extract it here now. So I have these. So I have this is what I'm looking for, x, y. Then I have m, which is 3, 9. that is 39. Then I have the object, this is minus 1, 3. So M is the midpoint. So you know how to get the midpoint of how do you get the midpoint of any line given the coordinates? This is what we do. If you take x plus the x value for r prime, then plus the x value, that is the coordinate, x coordinate for the other point here. This is what I mean. If I take x plus this, divide by 2, I'll get 3. So I'll take x plus negative 1. If you divide that by that, is how you get the midpoint. That should give me the x coordinate, which is 3. To give me 3 there. So I repeat. So if I get, I take this x coordinate, which is x, plus the x coordinate for the other point, then I divide it by 2. That is how I get the midpoint. I'll get this 3. Then for y, if I pick y plus the y value, the y coordinate for the other point, which is 3, I divide by 2, I should be able to get 9. So these are the two that will give me the values of x and y. So after getting that, now I can continue working. So this one will be x subtract 1 divided by 2 is equals to 3. Solving this, you'll get x subtract 1 is equals to 6. The x will be 7. Then for y plus 3 divided by 2 is equals to 9. So y plus 3 is equals to 18. And then y will be 15. So already we have the x and the y. So therefore, the coordinates of this point will be 7, 15. So that is how you work out that question. Alternatively, there's still another way you can use to get that by simply, I'll just draw it again here. I just draw the line again here. I'll show you how to get the point once again. So this is the midpoint, but this time I'll write it in form of in column form. So this is 3, 9. Then you have this one, this is r, this is the r prime. So this is I'll write it in column form, xy. I want to get this m. Then the object is negative 1, 3. Now we've said that these distances must be equal. This is how we get the distances. So negative 1, if I take this is negative 1, 3, I subtract 3, 9, that distance should be equivalent to, when I take m, this is a 3, 9, subtract x, y. Then should work because the distances must be equal. Subtracting these, negative 1, negative 3, give negative 4. 3 subtract 9, will give negative 6, is equals to, this will be 3 subtract x. This is 9 subtract y, like that. I'm working out these. So working out these, and these are what we're going to get. So this will be negative 4 is equals to 3 minus x. When you pick that, this is what you're going to get. You work out you solve for x here. You get x is equals to 3 plus 4, and therefore x is equals to 7. Also, you pick the bottom one. This is a negative 6 is equals to 9 subtract y, and this one will give y as 9 plus 6. So this will give y is equals to 15. So you can see you still getting the same thing. You're still getting the same thing using the second method. So r prime is equals to 7, 15. So therefore r 7, 15. So that is how you're supposed to reflect any point along any given line.